Algebra 2, lesson 13.4. Number 1 on page 689. A person invests $2,560 in an account that earns 5.2% annual interest. Find the value of the investment when it reaches $6,000. So the principal is going to be $2,560, and the rate is going to be 0.052. And we're going to use the formula. There's several variations, but if it's annual interest rate, annual interest rate, we're going to use f of t equals p times 1 plus r to the t power, okay? And that's just like the exponential growth. If it's more than annual, we'll say greater than 1 times a year, we're going to use f of t equals the principal. That's going to be 1 plus the rate over the number of times a year to the n times t power. So P is always principal equals P. And let's see, number R is always the rate. And number of times let's see, how do we say that? Just number of times a year is going to be N, and time, number of years, would be T. Continuously, if it's continuous, interest is done continuously. That's F of T equals P times E to the RT power. So you'll need to put those on your 3x5 card. So this is 1 time a year. We're going to use F of T equals P times 1 plus R to the T power. And that's going to be 2,560 times 1 plus the rate 0.052 to the T power. Now we're wanting to know when it's going to reach $6,000. So when does F of T equal $6,000? And we can do this in our graphing calculator. Let's see, on new document. No, let's go to graphs, and we'll type in, 2,560 times open parentheses 1 plus the rate 0.052 close parentheses caret. We got to use X with the graphing calculator. And remember, you can do this in Desmos as well. And we can't see it, so we're going to tab 6,000. 6, 1, 2, 3. And we got to get up there where we can see it. We know 6,000 is way up there. So menu 4, 4. And we got a couple of times. Now we're getting there. There we go. Escape. And then menu 6, 4. So if we do it, it's going to take 6.8 years. So T equals 6.8. All right, good. Now let's try number 2. A person invests $1,800 in an account that earns 2.46% annual interest. Find when the value of the interest investment reaches $3,500. So we're going to do like we did before. F of t equals $1,800 times 1 plus 0.0246 to the t power, and then f of t equals $3,500. And you can also do this one in your calculator, not on your graph. But if you see, this is f of t equals, all right, so we can set this $3,500 equals 1,800 times 1 plus 0.0246 to the t power. And we can go to our calculator and go to calculate, menu 3-1, numeric solve, put in 3,500 equals 1,800 times, open parentheses, 1 plus 0.0246, close parentheses, caret, and now we can use t. Don't forget to comma t, so we tell the calculator what we're looking for. And we get 27.36. So t equals 27.36. And if you do it in the graphing calculator, I just want to show you if you do it in the graphing calculator. On, new document, no, graph. It's going to round it a little bit. We'll put 1,800 times, open parentheses, 1 plus 0.0246, close parentheses, caret, and again, graphing, you got to use X, and then press tab, 3,500, menu 4, go up here a few times, and there it is, menu 6, 4, and that's going to give you 27.4. Okay, a little round in there. Okay, graphing gives you 27.4. Menu 3-1 gives you a more precise answer. Number 3, Emmanuel invests $3,600. Kelsey invests $2,400. Both investments equal 3.8% annual interest. How much longer will it take Kelly's investment to reach $10,000 than Emmanuel's? So if we do this, Emmanuel would be 10,000 equals 3,600 times 1 plus 0.038 to the t. Kelsey would be 10,000 equals, and that's $2,400 times 1 plus 0.038 to the t. And then how do we find it? Well, either way, you can graph it. Let's graph it. On, new document, no. First, I'm going to graph the 10,000. All right, and then tab, and then I'm going to do a manual. That's going to be 3,600 times, open parentheses, 1 plus 0.038, close parentheses, caret X, enter. I can't see it, so menu 4. Let's go up there to it. 2 more times, and there it is. Menu 6, 4. So a manual takes 27.4. T equals 27.4. Kelsey, I just need to change the 3,600 to 2,400. So let's go in here and change that to 2,400. 2400. Press enter. And notice that's 38.3. So T equals 38.3. So to find how much longer, that would be 38.3 minus 27.4. And I believe that's 10.9. Okay. Number 4, Jocelyn invests $1,200 in an account that earns 2.4% annual interest. Marcus invests $400 in an account that earns 5.2% annual interest. Find when the value of Marcus's investment equals the value of Jocelyn's investment. And then find the common value. All right, so Jocelyn, her investment is, let's see, 400 equals 400, and let's see, F of T equals 400 times 1 plus 0.052 to the T. Marcus, F of T equals 12. Hers was 1,200. See, I got them backwards there. Jocelyn was 1,200, and that was 1 plus 0.024 to the T. And Marcus was 400, and that's 1 plus 0.052 to the T. And if we'll just set these equal to each other, menu 3-1. Let's see. Let's go in here. Menu 3-1. Menu 3-1. And you can graph it as well, either one. And we'll set them equal to each other. So we've got 400 times, open parentheses, 1 plus 0.0552. Close parentheses, caret T, and then let's see, equals, and then we got 1,200 times, open parentheses, 1 plus 0.024 caret T, and then comma T, enter, and we get 40.7. So T equals 40.7. Now you can put that 40.7 into either equation. It doesn't matter. So let's see here, 400 times, open parentheses, 1.052, close parentheses, caret, and we'll put 40.7. And that gives us 3148.47. Okay. I wonder, let's go up here and grab this. And then get up there, and we'll delete that out. And then we'll go boom, boom, boom. Press enter, and then that will give us a very precise answer. And so the value of each of those accounts is going to be $3,152.42. Not too shabby. Number 5. Let's see. A person invests $350 in an account that earns annual interest compounded semi-annually. So here's where we change equations. So F of T equals the principal, and then 1 plus R over N to the T. So we're going to change. Now N is going to equal 2 because it's semi-annually. That means twice a year. Our rate, 0.0365. And we want to find it when it equals 5675. So 5,675 equals She put in $350. That's 1 plus 0.0365 over 2. And then we're going to have 2 times t there. Okay. You can graph it or you can do menu 3-1, menu 3-1, and I'll just do menu 3-1. And I got 5675 equals 350 times, open parentheses, 1 plus, oh, I want plus, control, divide, 0.0365 over 2, close parentheses, caret 2t, and comma t, press enter, and I got 77 years. So t equals 77. All right, it'll take 77 years. Number 6, Molly invests $8,700 into her son's college fund. That was kind of her, which earns 2% annual interest compounded daily. So N equals 365. R equals 0.02. And the principal is $8,700. Find when the value is $1,200. So we don't know what T is. We got to find T. So we got $12,000 equals $8,700. And that's going to be 1 plus 0.02 over 365. And that's going to be 365 times T. Okay. You can graph it. And let me show you how to do it if you can't graph it. So we got $1,200. And we're going to divide $8,700. Let's see. 0.1379. 0.1379 equals, and that's 1 plus 0.02 over 365. And that's going to be 365 times t. Okay, so now we've got to figure out how long it's going to take to get to that. All right, so we got open parentheses, 1 plus control divide, and we have 0.02 over 365. And then caret 365 times, and I'm going to shoot for 10 first. See what 10 gives us. 1.22, and I am looking for 1.2213, and I am looking for 0.187. What did I get over here? 1,200 divided by 87. I got 0.13. Okay, so why am I getting 1.22 here? $365 times. Let me graph this on new document. No, and let's graph this. And we got 12,000. 1, 2, 3. Enter, and then tab 8,700. Not plus, but times, open parentheses, 1 plus control divide 0.02 over, we're doing daily? Yes, daily, 365, there's 365 days in the year, caret 365 times X. And then now we need to get up there and see it. Menu 4, 4. There it is. Escape. Menu 6, 4. And we get 16.1. 16.1. So that was actually faster. 16.1. So t equals 16.1. Now, where did I make my mistake on that other side? 0.023. Oh, I did not. Let's see here. I see what I did. Yes, I didn't put the 8700 in front of it. So let's see. Escape. Let's put 8700, and then go up there and grab that. And that would have been, and we were looking to get to 12,000. Okay, so we would have had to. Let's go up there and grab that. Let's go up there and grab that. And let's change this to 16. And we had 16.1, and that's probably slightly over. Yeah, slightly over for rounding. Okay, there we go. So it works. Number 7. A person invests $200 in an account that earns 1.9% annual interest compounded quarterly. Quarterly would be 4. So N equals 4. And then the principal is $200. And the rate is 0.0198. Find when the value of the investment reaches $500. So we got $500 equals 200. And that's 1 plus 0.0198 over 4, and that's 4 times t. Okay, so we're looking to get to $500. So let's try it. Let's try it this way. We got 200 times open parentheses 1 plus control divide 0.0198 over 4 and caret 4 times, let's see, well, let's try 10. We'll start off with $10. That'll give us 243. We're looking for 500, so we need to go a lot more than that. Let's change it to, well, we'll double it. Let's see what happens. 296, that's not enough. And let's double that. This time we'll make it 40. 40 years, 440. Now we're getting close. 40. So we're not, let's see here. Let's go up there and grab it. So let's change that to 45. 45. 486, even closer, even closer. So let's go up there and grab that. And we'll put 47. 506. Now we're over. So it's somewhere between 45 and 47 years. So we'll split the difference. We'll do 46. And 46. That's just under. And look, that's 6 over. That's 4 under. So that's probably not quite 46.5. 46. We'll put 0.5 there. 501. So it's just under that. So we can say that T is approximately 46.4 years. Okay. And yeah, anyway. All right. Number 8. Hector invests $800 in an account that earns 6.9% annual interest compounded semi-annually. So Hector, semi-annually, so N equals 2, R equals 0.0698, and P equals $800. All right, Rebecca, 2 C's. Make sure I spell it right. Rebecca, her principal is $1,000, and her rate is 0.0543, and it's compounded monthly, so there's 12 months in a year, so n equals 2. Find when the value of Hector's investment equals the value of Rebecca's investment. Find the common value. So we need to find when, we need to find t, and it equals the value of Rebecca, and find the common value. So we need to find the value of t. All right. So we need to find those. Let's do this. We got 800, and then 1 plus, and that's, since that's 2, that's going to be 0.0698 over 2, and that's going to be 2t. And here we've got 1,000, 1 plus, and that's 0.0543 over 12, and that's going to be 12t. All right, the semi-annual. Rebecca had 1,000. He had here. That was big. Okay. All right. So I think we got it. Let's take a look at it. Now, let's graph it first. Menu, new document, no, and graph. And Hector, let's see, we got 800 times, open parentheses, 1 plus, control, divide, 0.0698 over 2. Caret 2x. All right, let's press enter. That worked. Press tab. And then we got 1,000. 1, 2, 3 times, open parentheses, 1 plus, control, divide, 0.0543 over 12. And we're going to go caret 12x. We've got to use x because we're graphing, not t. All right. Menu 4. We got to go up a way. Oh, we got the 2 lines right there. Menu 6, 4. And since we got the 2 lines, it will show us the intersection. It takes 15.5 years. And if you look, that gives you both. So t equals 15.5. Now, mind you, that's not the exact, that's an approximation, okay? And then the value of t is, and again, you're going to get approximation there. That's 2.31. Oh, quit that. 2.31 e plus 3. Now, that's scientific notation, and it means that's $2,310. Okay, e plus 3 means go to the right. 1, 2, and then 3. All right. Now, that's going to give you close, and you'll probably be able to find the right answer on the test. Okay, but if you want to be exact, go here, menu, trace uno, and then set them 800 times, open parentheses, 1 plus, control, divide, 0.0698 over 2, caret 2t, get the long line, equals, and then we'll put in 1,000, 1, 2, 3, times, open parentheses, 1 plus, control, divide, 0.0543, and that's going to be over 12. And then you need to get caret 12t, get the long line again, comma, t, enter. So it's 15.46. So now let's just take one of those equations, and we've got either one, it doesn't matter, 800 times, open parentheses, control, divide, and I needed to put a 1 plus in front of that, but we'll just 0.0543 698 over 2, and then let's go out in front of it. 1 plus, and then go out over here, caret 2 times, and we'll go up there and grab that, enter, and that gives us $2,310.98. So the actual T is 15.4616, and the actual V is going to be $2,310.98. Okay, so that's real close, and you would not go wrong doing that right there on the test. Number 9, a person invests $6,750 in an account that earns 6.23% annual interest continuously. Now we get to use the Pert formula, okay? And that's F of T equals P times E to the RT. That's why they call it the Pert formula. So P is $6,750. R is 0.0623, and we want it to reach a value of $15,000. So we got $15,000 equals $6,750 times E to the 0.0623 T. All right. Again, you can just graph that. On, new document, no, graph. And we've got $6,750 times E to the 0.0623. Got to use X, 0.0623, and then press enter. And tab, let's hit the 15,000. Enter, and menu 4. Let's get up there. Oh, I didn't want to do that. Menu 4. Get up here. Now we're one more. There we go. Menu 4. 12.8 years. All right, so T equals 12.8, and there we go. A person invests $465 in an account that earns 3.1% interest compounded continuously. So our principal is $465. Our rate is 0.031. And we want it, how long is it going to take to reach $2,400? And so we've got 465 times E to the 0.031 T. So let's take $2,400. $240, I think it is. No, $2,400. And we're going to divide $465 and control enter. 5.1612. So we got 5.1612 equals E to the 0.031 T. All right. So let's see here. There we go. So let's see here. 465 times E, the 0.031 times, and to go to 20, that's going to take a long time. So let's try 25. Oh, that's $1,000. Well, we're almost halfway there. So what if we were to double that? We'll make that 50. 2190. We're trying to get to 21. $2,400. So let's see here. We don't have to jump as hard this time. We're getting close. Let's try 55. 55. 25, 50. We're over now. And let's see. What would be half of that? We'll split it. So we're going to go 52.5. Oh, we're just under it. Let's go up there and grab it. And let's see here. Let's do 53 then. 53. That's right at it. That's right at it. Delete 52.9. Okay, so it's somewhere. There's a little, $4. I'm thinking 52.94 or something like that. So we're going to say T is approximately 52.9. Okay, that's pretty darn close. And might even be a little closer if we put it like that. Okay. All right. 11. Lucy invests $800 in an account that earns 6.12% annual interest compounded continuously. So we know we're in the E thing again. P is $800. R is 0.0612 continuously. Juan invests $1,600. Oh, so this is Lucy. And then Juan invests $1,600. So his principal is $1,600. And an account, so his rate is 0.039 compounded continuously. Find the value when Lucy equals Juan. So when Lucy's investment equals Juan's. All right. So we're going to have 800 times E, and the rate is going to be 0.0612 equals 1,600 times E, and don't forget to put the T there, 0.039 T. All right, let's do menu 3-1. And what do we got here? 800. Ooh, that's a little bit much. 800 times E, and we got 0.0612 T equals 1,600. Oh, Juan put twice as much in times E, but his interest rate isn't as high, 0.039 T, comma T, enter. And so in 31.2 years, so T is 31.2 years, and we need to know what's the common value. So let's go up there, and we got 800 times E, and that's 0.0612 times, and then we're going to go up there and grab that, and that gives us 5407. So the value at 31.2 is going to be 5407. Got that right. 0.00. Good job. Wrapping it up. Let's take a look at number. Oh, this is a little bit different here. Now, here is another formula. And this time what we're looking for, it says, Paula plans to make a deposit in one of the accounts shown in the table. To maximize the interest that the account earns, which account should you choose? Okay, those look pretty darn close, but one of them will earn you a little bit more than the other. Okay, so we're going to use this other formula, R equals, and that's going to be 1 plus R over N, that doesn't really look like an R, R over N to the N power minus 1. And then for the continuous, it's going to be, and this is even easier, E to the R minus 1. Okay, so I would put those on your thing. And this was at the very, very back. This was at the very, very back of your lesson, right back here. It was at the very back. There's your example. And started right up in here, and it's finding the effective annual interest rate. Because when you compound it more than once a year, the actual rate, if you were compounding it once a year, would actually be more. So we're finding the effective rate. Okay, we're finding the effective rate. All right, we're finding the effective rate. So we'll just call that the effective rate. All right, what is actually paying you. Okay, so here we go. Nominal interest rate. So for this one here, and this is continuously. So we're going to use this formula here. We've got R of X equals E to the 0.0283 minus 1. All right, let's try that in our calculator. E to the 0.0283 and then minus 1, and that's 0.0287 equals 0.0287. So it's actually paying 2.87% annually. And as you can see, that is more than that one there. Okay? Because that annually is, this one is, so you need to choose account X. And you can do that one too, and we'll put it in this other formula, and just to show you, R of Y is, and that's 1 plus the rate is 0.0286 over 1 time a year, and into the first power minus 1, and then we'll try that. Open parentheses, 1 plus control divide 0.02 is 86 over 1 to the first power, and then minus 1. And see, it gives you 2.8%. All right, so just so we can check. All right, let's try number 13. Tanika plans to make a deposit in one of two accounts. Okay, account A has 3.78 nominal rate compounded daily. Okay, so the effective rate of A is going to be 1 plus 0.0378 over 365 to the 365 power minus 1. And what do we got there? Open parentheses, 1. It's hard to find good help, folks. Sorry about that. Control divide. And we got, what was it? 0.0378 over 365. 365. And let's see, caret 365 minus 1. And that's going to give you an actual rate of 0.0385. Was that right? 385, yeah. Or 3.85% annually. All right, that's the effective rate. Now what about account B? RB has the 3.8%. See, it kind of looks more than that, but it's compounded monthly. Okay, so that's only 12 times a year. 1 plus 0.038 That's terrible penmanship. Tony's going to be mad at me. 0.038 over 12 to the 12th power minus 1. So let's do that. Open parentheses. 1 plus control divide 0.038 over 12. Close parentheses, caret 12. And then minus 1. Okay, so that's 3.866. So we might say that's 0.03866 8 or 3.87%. Okay, annually. So to maximize the interest the account earns, which account should you choose? Choose B. All right, it will make you more money over the long haul. 14. Kylie plans to deposit $650 in one of the accounts shown in the table. She chooses the account with the greater effective rate. How much money will she have in her account after 10 years? Okay, well, let's see. There we go. Account X. R of X, the effective rate of X is going to be 1 plus 0.0413 over semi-annually is twice, so that's going to be 2t, or that's going to be 2. We don't need the t on this. Minus 1. And let's see, open parentheses, 1 plus control divide 0.0413 over 2, and that's going to be close parentheses squared minus 1, and that gives a rate of 0.0417 equals 0.0417. 0.0417. Does it get any higher? No, then it's 2. Okay. Or 4.17% annually. Account Y. All right, that's going to give you 1 plus 0.0412, and that's quarterly, so that's going to be 4. And what it does, semi-annually, it pays you interest twice a year. Quarterly, it pays you interest 4 times a year. All right, so open parentheses, 1 plus control divide, and that's 0.0412. 0.0412. Quarterly is 4, caret 4, minus 1, enter, and that's 0.0418. So we got 0.0418 or 4.18%. Okay. So how much will it be? How much will it be worth after 10 years? So we're going to go F of T equals the principal, and then 1 plus, and the nominal rate, 0.0412 over, and then quarterly 4, and that's going to be 4T. So let's try that. So F of 10 equals the principal. It's going to be $650, $650, and then 1 plus that right there, 0.0412, the nominal rate over 4, and that's going to be 4 times 10. Okay, and that will give us how much it'll be worth. All right, so we got open, we got 650 times, open parentheses, 1 plus control divide 0.0412 4 caret and then 4 times 10. So it's going to be worth $979. That's $979. $979 and 33 cents. 32.6. All right. Well, I wonder how that other one would have done. And let's check it. So that's 4.3 semi-annual. Let's see how much that one would have been. Let's go up there and grab that one. And that was 4.13. So we'll put a 3 there. And it was compounded semi-annually. So we'll put a 2 there. And we'll put a 2 there. And let's see, $978. Oh, $978.25. So let's go up there and grab this one. Minus that one. And there we go. So $1.07. Now you're thinking, well, it's only $1. Well, you know, that was only putting in $650. What if they had put in more and more and more and more? Okay, that would have changed. That was one investment of $650. So there you go. Number 15. That's the one you get to do on your own. You get to try the different formulas and whatnot and stuff like that. What I will do is I will give you the correct answers. C, B, E, A, and D. But you must show your work to get credit. You must show your work to get credit. Folks, it's been wonderful. I have enjoyed it. I hope you have a nice week or evening, and I will see you on, tomorrow or Tuesday or Monday, depending on where it falls.